The product rule tells us how to take the derivative if we are multiplying two functions together. So naturally, I think this leads us to the next question of okay, what if we want to take the derivative and we're dividing two functions? What does that look like? So here, that's when we're going to talk about the quotient rule. This is kind of the case that this handles. It says if f and g are differentiable at x and g is not equal to 0. Here we're just saying this because we don't want to divide by 0 for any reason. If we want to take the derivative of f of x divided by g of x, that is equal to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. And I know what each and every one of you is thinking right now. You're thinking, why, but of course. It was so simple. The answer was in front of me the whole time. No, nobody's thinking that. Everybody's thinking, do I really have to memorize that? And of course, the answer is going to be yes. You do need to know the quotient rule. We can clean this up a little bit here. We can say g times f prime minus f times g prime divided by g squared. I don't know. I always thought that the quotient rule was a lot more difficult to remember. It just feels longer. And the other thing about the quotient rule, this minus sign actually matters quite a bit here. If you look back at the product rule, we were adding those two terms together. So it doesn't really actually matter what order you add them in as long as you have both terms. But when we have subtraction right here, the order makes a really big difference. So it's something that is just one more way that our problem can go wrong here. So luckily for you guys, though, I've got you covered. I've got a fun little rhyme here that will help us remember the quotient rule. It's something that I learned back when I was in AP Calculus, and I've never forgotten the quotient rule since then. So I'm going to write it down. It says low d high minus high d low square the bottom and away you go. So it's one of those fun rhymes that maybe you feel silly saying it out loud to yourself, but I do genuinely think that it will help you remember it. So I want to kind of talk about what this means. So when I say low d high, so I'm saying low, the denominator, and then when I say d high, I mean derivative of the numerator, derivative of the top part of my fraction. So my denominator, g, d high, derivative of my numerator, f. Okay, that's where that part comes from. Minus high, so okay, minus high, that's this guy right here, that's my numerator. D low, that's the derivative of my denominator, so that's g prime of x. Square the bottom, so that's g squared, and away you go. So I think that, I don't know, I've always thought that this was pretty helpful. I will oftentimes say it out loud to myself or kind of just say it mentally as I'm taking a derivative using the quotient rule just to kind of check my work and mostly out of habit. But I do think it's genuinely helpful in remembering the quotient rule because the formula is a little bit longer. And of course, I don't want to upset my communications colleagues here, so I want to make sure that I cite my source. This is from my AP Calculus teacher, Mrs. Schneider. Thank you, Mrs. Schneider, wherever you are, for teaching me this fun rhyme that I can now pass on to you guys. So we're going to just practice using the quotient rule here to find some derivatives. And I think the one thing I will say about the quotient rule that it's a little bit easier is that it's easier, I think, to identify when you need to use the quotient rule because you'll end up with something that kind of looks like a fraction. I think that this is kind of one way it's a little bit easier than the product rules, that usually the problems that require the quotient rule should be a little bit easier to pick out than problems that require the product rule because those, I think, are just a little bit more subtle. So let's look at a couple of examples here. So first I've got f of x equals x cubed minus 4x squared plus x all over x minus 2. And right now, I'm just going to lean on this rhyme right here. I'm just going to say it out loud to myself. If you want to use this formula, by all means go ahead. I just don't think that that's the best way to solve these problems, and so that's just not the way I'm going to do them. But if you would like to use the formula on your quizzes and exams and whatnot, by all means go ahead. So when I look at the quotient rule here, so this part right here, this is my low, this is my high. So f prime of x, the derivative, says low, so that's going to be x minus 2. D high, derivative of my numerator, so that is 3x squared minus 4x, minus 8x plus 1. So I have low d high minus high, that's x cubed minus 4x squared plus x. D low, derivative of my denominator, derivative of x minus 2 is just 1. Square the bottom, x minus 2 quantity squared, and away we go. So here's the first step of my quotient rule. A few things that I'll point out here. You do want to make sure that we use parentheses wherever we need them, because we do need to make sure that we're distributing this minus sign right here. It's really easy to overlook that if we don't have the parentheses where we need them. So please just make sure that you are using them. And then the numerator is really what I want to focus in on. This is really what I want to clean up. The denominator here, I'm going to tell you right now, don't worry about simplifying the denominator. We can actually leave that as it is. We're not going to worry too much about that. So the numerator, I do have a little bit of multiplication, and here I chose my problem poorly. I have kind of an ugly multiplication to do, but that's okay. We can do it real quick. I should have 3x cubed minus 8x squared plus x minus 6x squared plus 16x minus 2. This minus sign, I'm just going to say we have to be very careful with it. I'm going to, well, and in this problem it's not too bad. Usually if I have another factor over here, like this 1, I will take that 1 and I will distribute it here to each and every one of my terms first before I take care of this minus sign. But because it's just a 1, it's not, multiplying by 1 isn't going to change that number. I am going to go ahead and take this minus sign, I'm going to change it to plus, and then change all of the signs that follow it. So I should have minus x cubed plus 4x squared minus x divided all by x minus 2 quantity squared. At this point, my numerator is very long. All I need to do, though, is combine my like terms. That's really the only thing I'm going to ask you to do here. So let's see, I have 3x squared minus, 3x cubed minus x cubed. I will have 2x cubed. Negative 8x squared minus 6, I'll have minus 14. Plus 4, I'll have minus 10x squared. X plus 16 would be 17, minus x would be plus 16x, and then I only see that minus 2 there, so minus 2 divided by x minus 2 quantity squared. Here is my derivative. This is f prime of x. So quotient rule problems do tend to be a little bit longer. This one was kind of especially long because we had this trinomial right here. That was really why this one was a little bit more difficult. But I think in general, quotient rule problems do tend to be a little bit longer than product rules. And we just need to kind of take our time and be careful, very deliberate with these problems so we don't make a silly algebra mistake. Let's look at the next one. I think this one will be a little bit easier to work with. So here I have g of x equals 2e to the x plus 1 divided by 2e to the x minus 5. If you need to, you can also take some time off to the side over here if you want to say, this is your, I don't want to use F and G, but if this is the top and this is the bottom here, T prime is equal to this and B prime is equal to that, if you want to lay out exactly what this is so that you don't have to take derivatives on the fly. But I'm just going to jump in head first here. G prime of x, the derivative. So low, that's this guy right here. So 2e to the x minus 5. D high, derivative of my numerator, so the derivative of 2e to the x plus 1. Well, the derivative of 2e to the x would be 2e to the x. And then the derivative of 1, that's just a constant, so that's just 1. Minus high, so that's 2e to the x plus 1 again, so 2e to the x plus 1. D low, derivative of my denominator, derivative of 2e to the x minus 5. Well, that again is just going to be 2e to the x divided by 2e to the x minus 5, square the bottom, and away we go. So there's a few different ways you could simplify that numerator. If you wanted to, I see a common factor of 2e to the x. I could factor that out right now if I wanted to. But let's suppose we didn't see that. It's okay. I'm not going to ask you to factor these entirely. Here, I'm just going to go ahead and distribute that 2e to the x, so I should have 4e to the 2x power if I add those exponents, minus 10e to the x. And the reason I especially don't want to factor is I want to show you how to handle this minus sign, because I do think it's a little bit tricky. So I'm first going to distribute this 2x here, so I'm going to say minus 4e to the 2x, and then let's see, plus 2e to the x. Denominator will stay exactly the same. And notice how I use parentheses. I use parentheses again in that numerator in that second step, so that I know that in this step, okay, I need to take this minus sign, I need to distribute that through. So just please be very, very careful with that. And I should be able to combine my like terms. 4e to the 2x minus 4e to the 2x, those two will cancel. And then what do we have after that? I've got minus 12e to the x divided by 2e to the x minus 5, quantity squared. There is my derivative. Let's look at one more before we hop into an applications problem here. H of x equals e to the negative x. You might look at that and you might say, well, that doesn't look like the last two problems, right? You said quotient rule would be easy to pick out, right? You said it would look like a fraction, like this, 2e to the x plus 1 over 2e to the x minus 5, or, this guy right here, it's going to look like a rational function. It'll look like a fraction. So this one right here, we don't know how to take the derivative of it, but kind of like we did earlier when we had those workarounds, I can rewrite this. I can rewrite a negative exponent, and this is going to be a really important idea later on in this section. If I have a negative exponent, I want to make it positive. If it's in the numerator, like this one is, if I take that and bump it down to the denominator, and I say that this is 1 over e to the x, I can make that positive. Now, I think this looks an awful lot more like a quotient rule problem. Now I think it's easier to pick that out and say, yep, that is 100% going to be a quotient rule problem. So let's use our quotient rule here. H prime of x says low, e to the x. D high, derivative of my numerator. So the derivative of 1, that's just going to be 0 since 1 is a constant. Minus high, that's 1. D low, derivative of e to the x, but that's just e to the x. Square the bottom, e to the x squared, and away we go. So we're just simplifying this. E to the x times 0, that's just going to be 0. So I have negative 1 times e to the x, that'll be negative e to the x. And I said earlier, don't generally worry about the denominator. Here's kind of the one case where I do want you to worry about it. If you just have a monomial like e to the x right here, I think, yes, we can go ahead and simplify that. So this really says just e to the 2x. And then I can cancel a factor of e to the x. That would leave me with negative 1 over e to the x. We could leave our answer like that, or we could say negative e to the negative x power. Either one of these would be perfectly fine. So there is my derivative using the quotient rule. I want to look at one more example here. Our good old friend, equation of the tangent line, making a comeback. Find an equation of the tangent line to the graph of f of x equals 2x squared over 3x minus 1 at a equals 1. So again, here I see this rational function. It kind of looks like a fraction. This to me looks like we're going to need to use the quotient rule. So I have an x value, right? This isn't, let's use x equals 1 instead of a equals 1. I have an x value, which means I need two things. I need a y value, I need a slope. Again, how you find those things, in what order, that's up to you. I'm going to find the y value first just because I don't have to do a whole lot of work for it. To find the y value, I'm plugging my x value into the original function. So this is 2 times 1 squared all over 3 times 1 minus 1. Let's see, this is 2 over 3 minus 1. 2 over 2, this is 1, so my y value is 1. So I have my point. I need my slope now, and then I need the slope of the tangent line, which means I need the derivative. So I need to find the derivative of this function, which means I need the quotient rule. So f prime of x derivative says low, so that's going to be 3x minus 1. D high, derivative of 2x squared, that will be 4x minus high, that's 2x squared. D low, derivative of my denominator, that's just 3 here. Square the bottom, 3x minus 1 quantity squared, and away we go. So that numerator is really just what I want to simplify. I can distribute the 4x, so I have 12x squared minus 4x minus 6x squared all over 3x minus 1 quantity squared, which would give me 6x squared minus 4x divided by 3x minus 1 quantity squared. Here's my derivative. So I have my derivative. I now want to take the x value that was given to me and plug that in so that I can find the slope of the tangent line. So f prime of 1, this is 6 times 1 squared minus 4 times 1 all over 3 times 1 minus 1 quantity squared. So I've got 6 minus 4 all over 3 minus 1 squared. Let's see, 2 over 2 squared, this is 2 over 4, which is 1/2. So my slope of the tangent line is 1/2. So I have my x value, have my y value, have my slope. I'm ready to go. So let's write the equation of this tangent line. Y minus my y coordinate is 1. Equals m, that's 1/2 times x minus my x coordinate is also 1. Y minus 1 equals 1/2 x minus 1/2. Adding 1 should give me y equals 1/2 x plus 1/2. There we go. So even though we have these new derivative rules, right? Even though we have the product rule and we have the quotient rule, they still tell us the same things. The derivatives at the end of the day, even when we use the product and the quotient rule, still tell us slope of the tangent line. They still tell us velocity. So when we do something like find the equation of the tangent line, even though I had to use this new quotient rule to find the derivative, it still ended up telling me the exact same thing. It told me the slope. So the way I find the derivative, yes, is a little bit different, but the way I interpret it, that part has not changed. The derivative still tells me the same exact piece of information that it did before.